Hello guys, and welcome back to Introduction to Number Theory. This time I would like to discuss prime elements. We have all heard a lot about prime elements and factorization into prime factors and many other things about prime numbers. But what does being prime mean? Let's consider several examples just to show you what this notion actually means. First example, well, if we have just two integers and their product is even, then we understand that at least one of these integers must be even. But what does it mean even? Even means divisible by 2. Well, okay, another example. Just take two integers which product is divisible by 3. Or just a small thinking, and we can conclude that at least one of these integers must be divisible by 3. Well, we can actually prove this. Let's just consider all possible remainders when divided by 3, and when we understand that A can have remainder 0, 1 or 2, and also B, and when combining these remainders, we understand that their product can give remainder 0 only if one of these two factors, A or B, is actually divisible by 3 and has remainder equal to 0. Well, so here we have several examples where when product is divisible by some number, then one of the factors must be divisible by the same number. But let's consider another case. Say if product is divisible by 6. Can we now claim that one of these numbers, A or B, must be divisible by 6? Well, actually not. And we have an easy counterexample. Say we can take A equal to 4 and B equal to 9. So neither 4 or 9 is divisible by 6, but their product equal to 36 is, of course, divisible by 6. So what is the difference between these cases? Well, the answer is being prime. Prime numbers, prime elements, are those elements that act like 2 or 3. And 6 is not prime. Now we should give a definition. So consider a ring, and we say that an element of this ring is prime if, according to our previous cases, well, of course, P should not be invertible. Invertible elements, we do not touch them. We just play with other elements that are not invertible. And we say that P is prime if for any two elements A and B such that their product is divisible by P, we can conclude from this that either A or B should be divisible by P. So this property actually defines prime elements, prime numbers. Well, let's consider an example. Consider ring of polynomials in one variable, and consider a polynomial, say, x minus 7. Well, we all, I believe, understand that this polynomial, well, it really seems quite prime, but let's try to prove this using the definition. Now, suppose that product of two other polynomials, A and B, is divisible by P. This means that AB product is equal to P, which is x minus 7, multiplied by some other polynomial C. From this, it follows that if we substitute x equal to 7, we gain 0 on the right-hand side. So the left-hand side must also be equal to 0. So product of values of these polynomials A and B in the point x equal to 7 this product is equal to 0. So now we understand that either A or B has a root equal to 7. And this means that either A or B must be divisible by P. So this way we proved that P equal to x minus 7 is indeed prime in the ring of polynomials in one variable.